All right. All right, all right, all right, all right, all right, all right, all right. So, welcome on in, everyone. Hopefully, everyone has enjoyed their Sunday. I am Robert, the AP Math Guy, and today, let's talk about something that has been requested from one of our viewers, and that would be the squeeze theorem. So I will go ahead and check it off the list. And here comes my cat. Right, come on. Here, kitty kitty. 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 Yeah. Welcome on in. OMG, your calc teacher talked about this and you don't understand it? Well, you came to the right place, because tonight we're going to be talking about it. So yeah. So as you're coming into this live, let's go ahead and see some hearts. Show that we are excited and ready to get started. You're doing your calc homework right now? I guess it's perfect timing then. So yeah, like I said, hopefully everyone's had a good Sunday evening. I know I have. I did my first fantasy football draft today. Apparently I did the best job because the Yahoo seems to think that I'm going to win the whole thing. So yeah. So that's something, because I'll be honest, I've never actually won a draft before. So today I've been playing for like almost a decade and a half, and today was the first time I ever got the top grade in a draft. So yeah. And the funny thing is I picked second, so yeah. All right. So thank you all for your likes. Thank you all for the view. Thank you all for joining us this evening, or joining me this evening. I don't know if I should refer to everyone as us, or if I should just talk about me. But you know what? It is what it is. And for those of you who I can't click and say hi to, I'll wave at you now. There we go. So, let's talk about the squeeze theorem. For a second I thought I was out of frame. So, what is the squeeze theorem? So the squeeze theorem is basically defined as the following. Suppose I have three functions, and I know the relationship of those three functions as the following. So I have please don't cross out your Z's. Personal habit, but yeah, so theorems aren't defined. Nope, but functions can be. So let's say I have three functions. I'm going to define them as f of x, g of x, and h of x. And I know about these three functions that g of x is less than or equal to f of x, or greater than or equal to f of x, but less than or equal to h of x. And I know at some point, x equals a, f of x is going to equal h of x. Therefore, at that point a, because f of x and h of x are equal at that point, then g of x must also be equal to f of x and h of x at that point. So that is the very basic idea of the squeeze theorem. Now, we use the squeeze theorem mostly to talk about limits of functions, especially functions that we can't necessarily solve either algebraically or through another method, such as the what was I gonna say? I don't remember. Anyway, so I can't. So I'm going to use this one for limits that I can't necessarily solve either algebraically or through another method such as L'Hopital. So let's go ahead and try our first example. Why does it seem like this camera is a little off? That's better. What level of calc is this? I start calc 1 in a week. This is calc 1. So yeah, let's go ahead and try our first example of this. So, example. Ugh, okay. Fair enough. Thank you, Kenobi, for sharing the live. So let's go ahead and start our first problem. So I'm asked to evaluate the limit as x approaches 1 of f of x, and I'm given... Thank you, Paranshu, for sharing the live. So I'm given the following. I'm given that 5 is less than or equal to f of x, which is less than or equal to x squared plus 6x minus 2. So, how would I determine this limit using the squeeze theorem? Well, I don't know what f of x is, but I know whatever it is, x is approaching 1. So what I'm going to do is I'm going to take the limit of all three of these expressions. So I'm going to take the limit, let's see if my pen is going to work tonight. There we go. Limit as x approaches 1 of 5 is less than or equal to the limit as x approaches 1 of f of x, which is less than or equal to the limit as x approaches 1 of x squared plus 6x minus 2. So from here, I can't actually plug in I can't plug in 1 for x to this leftmost expression because I have nothing to plug it into. So the limit as x approaches 1 of 5, well, that's just going to be 5, is less than or equal to the limit as x approaches 1 of f of x, which is less than or equal to, well, here, unlike the one all the way here I can plug in 1 for x. So I have 1 squared plus 6 times 1 minus 2. So here, on the left I have 5. Approaches 1 of f of x is less than or equal to. What is this going to be? Well, 1 squared is going to give me 1, and 6 plus 1 is going to give me 6. So I have 1 plus 6 is 7. 7 minus 2 is going to give me 5. So here, I now have the inequality 5 is less than or equal to the limit as x approaches 1 of f of x, which is less than or equal to 5. Well, here's where we have an issue, because I don't have a there's no value such that that's both greater than and less than 5. However, there is a value that is equal to 5 and equal to 5, and that would be 5. So, therefore, by the squeeze theorem, theorem, the limit as x approaches 1 of f of x is equal to 5. Thank you, MZ Yans, for the follow. I squeeze theorem. Yes. Yes, indeed. So, yeah. No, welcome. You're welcome, Piranshu. I'm really happy to explain, and we're gonna have a few more examples tonight. I'm taking calculus 1. This is very helpful. I'm glad to hear that, Kyler. How are you doing so far? I hate calculus so much. I'm sorry to hear that, Nick. Hopefully after tonight's live, you'll like hopefully you like calculus, even if it's like 1% more, or any percent more. If it's, as long as it's non-zero and it's positive, then I will take it. Dual L'Hopital problem. So tonight we're actually focusing on squeeze theorem, Gorilla. So it's just going to be both the numbers. Ideally, we want to have a situation where I have the same number on both sides of the inequality, so it forces this to be that number. Yeah. I have a B+ in college first year. Congratulations, Kyler. I'm really happy to hear that. I've just took it at Penn State, so glad it's done. Fair enough. Fair enough, Nick. I've taken Calc 1 through 5. That's awesome. That's really cool, Gorilla. Thank you, Cobra, for the follow. And thank you, Norma, for sharing the live. Oh, wow, 55 people in here. Let's go. I think that's a new record. I'm not sure. I'd have to check that later, but I'm pretty sure that's a new record. So thank you all. Calc 3 and up. Okay. Do you teach calc at high school or college? I used to teach calculus, but I don't. I tutor now. I left the classroom back in 2018. I found it wasn't for me. Although you would think that the lesson I would have learned last night was to have more than one water here. I guess I didn't. Thank you, Linda, for the follow. I love my calc teacher. She's so goated. Perfect. Fantastic. Thank you, Jer, for the follow. Okay. How much longer are you going to be streaming? My goal tonight is to go about an hour and a half to 2 hours. So I just started about 15 minutes ago, so we have plenty more problems tonight, Pranshu. We have plenty more to go. I wanted to start off with a little bit of an easy. When you say force the numbers to both be the same, how would you do that? Well, Ah, the squeeze theorem, one of my faves. Awesome. Hi, Sal. How are you doing? So when you say force the numbers to both be the same, how would you do that? So essentially, what I'm doing is I'm gonna be So essentially, my goal is to take limits of two functions that I know to find the limit of the function I don't know. So, like that, this is just the first example of a few tonight. Thank you, Zaba, for the follow. If I'm learning this right now in school, do you think derivatives are coming up next? Yeah. So you're gonna be, if you're taking AP, the course usually does, and like that, it's been a few years since I've actually taught the course, but from what I've seen from students who have taken it recently, once you're here, you're gonna be about maybe 2 or 3 weeks before you get to derivatives, but you're gonna get there soon. Thank you, Luke, for the follow. Hey, I'm all right, brushing up on the calc skills again. Awesome. Well, you've come to the right place. Most of the squeeze theorem, intermediate value theorem, etc., they give you pretty much everything you need. Yep. I'll just wait then, lol. I haven't learned limits yet, but I have an idea of what it is. Okay. Cool. The AP exam fantasy is so easy. We've only just begun. I'm in Calc AB as a junior in high school. That's awesome. That is really cool. I had to wait until senior year to take it. But I had a few, there were a few juniors in class already. Yo, I'm worried for it. I just got started and I'm already lost. No problem. And please, if you need to ask a question, please feel free to do so. A limit is just approaching the value of x from the left or right, or the top or bottom from y. What's limit of f of x? Well, alright, so just as a quick review of what a limit is, a limit tells us what y value we're approaching as x gets closer and closer to a certain point. My teacher had a 100% pass rate, so I trust in her. Awesome! Memorizing the unit circle is a must. Agreed. Absolutely agreed. Or the ability to, or maybe not memorize it, but at least the ability to derive the basic values from the unit circle, I would say. But yeah, so let's try one. Memorize quadrant 1 and the rest is mirrored. Yep, exactly. So let's go ahead and try another one like this, and then we'll get into some of the formula, some of the squeeze theorem problems you might see. So, gotta watch the algebras? Absolutely. They say the hardest part of calculus isn't the calculus. The hardest part of the calculus is the algebra. So, let's say I want to evaluate the limit as x approaches 2 of f of x given the following. Someone in the comments, or anyone, should I major in math? It really is up to you. How do you feel about math overall on a scale of 1 to 10? I'll never take Calc 3 then. Calc 3, I'll say this, I agree with Gorilla. Calc 3 is easier than Calc 2. So, I think I got that right. Cool. So given this, I want to find the limit as x approaches 2. So this tells me that f of x, whatever it is, I don't know what it is, but all I know is that it's always, f of x is going to be in between 2x squared and x squared plus 3x minus 2. So what I'm going to do is I'm going to go ahead and take the limit of all three sides. So I'm going to have limit as x approaches 2 of 2x squared is going to be less than or equal to the limit as x approaches 2 of f of x, which is less than or equal to the limit. I hope I gave I'm pretty sure I didn't give myself enough room for this, but we'll make it work. So this is x squared plus 3x minus 2. Oh, barely enough room. So from here, I'm going to plug in 2 everywhere I see an x. So here, I can plug in 2. So I have 2 times 2 squared is less than or equal to the limit as x approaches 2 of f of x, which is less than or equal to 3 times 2 squared plus 3 times 2 minus 2. Thank you, Ash, for the follow. I have a feeling I missed something. Anyway, so thank you, Billy's version, for the follow. So here, I have 2 squared is going to give me 4, and 4 times 2 gives me 8. Limit as x approaches 2 of f of x. And then on the right side, I'll zoom in a bit so that way you can see it. And I will also focus the camera. There you go. So if I solve that, what would I end up getting? Yenny says 8. We learned this last class in my calc class. Perfect timing. OMG, are you teaching on an Elmo? What's an Elmo? I'm not sure what that is. So yeah, here, Yenny, yeah, it's 8. Why? Because 2 squared is 4. 3 times 2 is 6. 4 plus 6 is 10. And 10 minus 2 is equal to 8. Elmo is a newer version of an overhead projector. Hey, Hefe, how are you doing? So, no, I'm not actually teaching on an Elmo. What I'm teaching on is a document camera. Congratulations, Ryan, on your 4. I'm doing good. It's a good Sunday night. So here, thank you 1 and 3 for the follow. So here, I have 8 is less than or equal to the limit as x approaches 2 of f of x, which is less than or equal to 8. So here, there isn't a value that's both greater than 8 and less than 8. But there is a value that is equal to 8, and that would be 8. So therefore, oh, I forgot to mention, these 3 dots in this triangle formation is just, therefore, means therefore. By the squeeze theorem, the limit, thank you, Sherry, for the follow. So the limit as x approaches 2 of f of x is equal to 8. Thank you, Ryan, for the follow. And that's it. So, any questions so far after 2 problems? As it is now, it's no longer Sunday here on the East Coast, it's now Monday morning. Is this calculus? Yep, this is calculus. This is calculus 1. What does it mean? Are you talking about this? Oh, okay. So this isn't the limit of 2. This reads as the limit as x approaches 2 of f of x equals 8. So what that means is that if I draw a function, as I approach the point x equals 2, or as I approach the point x equals 2, y is approaching 8. Now keep in mind that this doesn't mean that f of 2 is 8. It just means that we're approaching 2 from both the left and the right, y is approaching 8. Or the function approaches 8. F of x is the same as y, yes. F of x is just a fancy way of saying y. Why? I wasn't at the naming convention, so I can't actually say with certainty why. Thank you, Key, for the follow. Thank you, Yeshua, for the follow. Cool. Thank you, James, for the follow. So let's go ahead and start another one. You start college calc on Tuesday? Awesome. What's the y-intercept? I'm not sure, because I actually don't know what f of x is, so I can't say for certainty. I can't say for certain what that y-intercept is. Yet I don't know what the function is. Y used in in algebra? So remember that y is the same as f of x, but in calculus we want to keep things to one variable if possible. So that's why we choose to use f of x instead of y. And my cat is back. All right, down. All right, come on. So that's why we don't use y. All right, I gotta go for my study for my stats test tomorrow. Best of luck to you, Ryan. Hopefully you do well. Wait until you see y prime. Yeah, so that's why that's why I choose to use f of x, is because because I only want to deal with one variable at a time. of what use is this? Just curious. So let me do a quick Google search, because I'm sure if you Google that question, you will find your answer. So it can help us describe physical phenomena. It can help us with computer science. It can help us make predictions about the market. Hey, can you show that the natural numbers form in a abelian group under multiplication? So tonight, Ernie, I'm just working on calculus, but when I get to abstract algebra, I can definitely do that. But tonight I just want to focus on the squeeze theorem. No problem. So let's try another exercise. Do I what theory? I don't know what that is, Ernie. I'm afraid. Thank you, Ernie, for the follow. But yeah, I'm not sure what that is. So, let's go ahead. Can you tell me what LIM means in mathematics? Sure, it's just limit. So it tells us as we get closer and closer, as x gets closer and closer, infinitely close to this, then that's what, then it tells, so as we get infinitely closer to this, y gets infinitely close to that. Okay, what does it mean? I'm not quite sure what you're asking. Basically, ergodic theory defines the statistics properties of chaotic systems. Is how we... Okay, cool. I didn't know that. Is this how they build bridges? So the math that helps build bridges is called differential equations. But yes, it is built from this. I kind of answered. Okay. So let's go ahead and try a problem like this, but this time let's actually define f of x. So I'll give f of x a name. So let's try another example. So find the limit as x approaches 0 of x squared times sine of 1 over x. So I'm going to say this for the remainder of the evening. Actually, I need to readjust my camera. There we go. So for the remainder of the evening, my x value that I'm going to approach is 0. Yeah. So, here's what we're going to do. So, if I plug in 0 right now, will this function be defined? Yes or no? What do you think? Will this be defined at 0? Okay. Okay, Fem says yes. If it is, what would the value be? Usher says 0. Well, it could be 0, except what happens when I plug in 0 for this x? Well, when I plug in 0 here, right, it wouldn't exist, right? Because I can't divide by 0. So I can't assume that this is going to be 0 because, right, 1 over 0 is undefined. So here's what I'm going to do. I'm going to use the squeeze theorem to find this limit. So how would I do that? Well, I'm going to take a look at my functions here, and I'm going to make an observation about them. So let's talk about x squared for a second. So x squared, is x squared bounded? By that I mean, is there an absolute minimum and an absolute maximum to x squared? Or is it unbounded? So we'll forget about that for a moment and just focus on x squared. Is it bounded or unbounded? Ash says bounded. JJ says yes, it's a quadratic. Santiago says unbounded, so it looks like we have a bit of a x squared is unbounded on R. Bro says it's positive. Kind of Maffey said that x squared is unbounded on R. Right. So and R is what I care about. So here, the minimum of this is going to be 0, but the maximum of that is going to be infinity. So because the maximum is infinity, this x squared is an unbounded function. I probably should have defined that earlier. I apologize for that. Now, let's focus on sine of 1 over x. Is sine of 1 over x bounded or unbounded? And if it is bounded, what is the maximum and minimum? Sine is bounded between negative and positive 1. Santiago says yes. Hefe says bounded. User says unbounded. Azab Academy says bounded. Yeah, it's bounded. So the bounds of sine of 1 over x, well, the bounds of sine, so bounds of sine of x is this. So negative 1 so here are the bounds of sine. So sine cannot be less than or cannot let me try that again. So sine is less than or equal to negative 1 or greater than. Wow, I can't read tonight. Sorry about that. Let me try that one more time. So sine is greater than or equal to negative 1. There we go. But less than or equal to 1. Right. So as you can see, I make a ton of mistakes. And I'll be honest with you, that's not going to be the first mistake I've made, and it's not going to be the last mistake I make. So, so yeah. So it turns out that sine of whatever's inside my parentheses are also going to follow these bounds. So I can say that sine of 1 over x is also going to be bounded in that. But I don't want sine of 1 over x. I want x squared times sine of 1 over x. I'm not assuming it's 0. I solved it by u sub algebraically. Cool. Thank you, kind of Maffey, for the rose. I don't know if you just did that or if that's been there for a while, but if it's been there for a while, I apologize for missing it, but thank you. So, now, what I can do is I'm going to go ahead and multiply everything here. So, essentially my goal is to get this middle term to match my original problem. So, what I'm going to do next is I'm going to multiply both sides by x squared. Couldn't you rewrite as limit approaches, as x approaches 0, sine of 1 over x? Nope. Here's why. Because I'm not multiplying x squared by 1 over x. Sine is essentially I kind of like to think of it as its own operation. So sine of 1 over x is different than just 1 over x. If it were x squared times 1 over x, absolutely I could do that. Or even then it would just be x. Or sine of 1 over x divided by 1 over x squared. Could I? I'm not sure how you're arriving at that. Are you taking the derivative of this? Right, but I think that right, you're right on that, but I think we're overthinking it a little bit. So here, I'm going to go ahead and multiply by x. I'm going to multiply everything here by x squared. Now, because I have an inequality, I need to consider whether I need to flip the signs. Because when I multiply or divide by an inequality by a negative, I have to change the signs. But what do we know about x squared? Well, x squared, unless we're dealing with I, can never be negative. So, and this isn't complex analysis. This is Calc 1, so we can ignore I. So I know that x squared, y equals x squared, is always going to be positive. So I don't have to worry about flipping those inequality signs. So here, I have negative 1 times x squared, so that's going to be negative x squared is going to be less than or equal to x squared times the sine of 1 over x is less than or equal to x squared. And now that I have this that matches here, all I need to do now is take the limit. So now I'm going to take the limit as x approaches 0. I hope I gave myself enough room for this. Of negative x squared is less than or equal to, why isn't my pen working? There we go. Limit as x approaches 0. I'm more than sure I didn't give myself enough room for this. So this is going to, I apologize if it gets a little messy. Sandwiching lemmy, yeah. So this is also called the sandwich theorem. I'm gonna write this here, but I'm gonna write my function down here just because I didn't give myself enough room. So limit as x approaches 0 of x squared. So now I'm gonna go ahead and plug in 0 here and here and see if I get anything interesting. So the limit as x approaches 0, what is the limit as x approaches 0 of negative x squared? What do we get by plugging in 0 into negative x squared? Santiago says 0. Always Lou says 0. GH says 0. Paper Chip says 0. Awesome name. WP says 0. Thank you, Michael, for the follow. Kind of Mathy says 0. Yeah, so it looks like we've reached a consensus and agree that this is equal to 0. Not quite, Yeshua. Right. Well, right. Why? Because if I plug in 0, I get 0 squared. 0 times 0 is 0. And then there's no such thing as negative 0. So we just write it as 0. And I'm going to let that be there. X squared sine 1 over x. And then if I plug in 0 for x squared, I also get 0? Same logic would apply for x sine of 1x. You just yes, absolutely. I agree. WP says yes. Santiago says yes. Yeah, so this would just be 0. Last time I checked, there aren't any negative numbers that are greater than 0, or yeah, negative numbers that are greater than 0, nor are there any positive numbers less than 0. So I have 0 is less than or equal to this, which is less than or equal to 0. And here, because I have 0 at either end of my compound inequality, I'm going to write my 3 dots in their triangle formation by squeeze theorem. Limit as x approaches 0 of x squared times sine of 1 over x is equal to 0. Do I have an example like this that isn't trig? Personally, I have none prepped that are outside of trig. I'm glad you mentioned that, Joe. I can't actually use L'Hopital here because it doesn't meet the condition. Thank you, Santiago, for the follow. How do you get from the inequality with sine x to the inequality with sine of 1 over x? Okay, good question. So, here, sine of x is bounded by negative 1 to 1. So, we agree on this. So it turns out that if I have anything inside the parentheses, it's not going to change these bounds. The only thing that could do that is if I multiply something out front, like if I had 2 times the sine of x, then it would increase these bounds. It would make it negative 2 and 2 respectively. But because I'm not multiplying my sine by anything, and I'm only changing what's inside here, this is also going to be bounded by negative 1 to 1. In fact, graphically, we can see that. So I'll show you the graph of both of them. So, all right, turn that on, clear that, and clear that. That was an example from last night. So let me go ahead and decrease the brightness on that a little bit so that way we can see it a little better, or move it up. That might be a better idea. So sine of x and sine of x divided by 2. Oh, I don't even need that parenthesis, do I? Right, because I'm not doing any other I'm only doing one operation inside there, so it doesn't matter. So, let's graph both of these. Oh, let me set my window. So, negative 2 pi. Nope, I don't want that to be the min. So, let's try it one more time. Negative 2 pi, there we go, to 2 pi. And we'll make our scale, or that'll work. So here, all this does is it talks, it fixes the what's the word I'm looking for? Period, right. Yeah, it's almost 12:30 in the morning. So, yeah, it adjusts the period but not the amplitude. If it were to adjust the amplitude, then it would be taller or shorter. But here, since I'm only adjusting the period, it's not going to make it taller or shorter. So it's still bounded between -1 and 1. I start AP Cal 8B tomorrow, and I'm going from algebra to trig, skipping over pre-calculus. Any tips? So when you took algebra 2, I know some classes teach more about trig than others. Did you go over the unit circle, Will? Or any of the Pythagorean identities? So you can basically do whatever you want to sine of x as long as the result doesn't go above 1, or not necessarily, but as long as it doesn't, like if I have 2 times sine of 1 over x, then I would have to change my bounds. I could still do the squeeze theorem, but so for tonight, all of these are going to be between -1 and 1, just to keep it easier. Does the theorem only work for the product of two functions? Can it work for a sum or difference? We shall see. Right. Yes, Usher. Thank you, Chris, for the follow. I took 1 year of Algebra 2 and 1 year of trig, and yes, I did unit circle. Perfect. Do I know the epsilon delta proof? I do. Thank you, Tanya, for saying that. Yes, he does indeed. Thank you, Will, for the follow. But yes, I do know epsilon delta. I'm not going to do it. I'm not going to go over it tonight, but I can add it to the list if you would like me to. I will say this, though, it is a little complex. Like that, I'm not going to say that, thank you, WP, for the follow. So with that, I believe it is now time. Do I have enough room here? I might have room. If I am careful, I should have enough room. So let me go ahead and block that off. And I'll move my camera up a little bit. I've heard about limits and derivatives and stuff, but I don't know those at all. Should I? Yes, please tap. Please tap. It shows that you're engaged with my live. I saw that someone sent me something, so thank you, Gen T, for heart me. Yes, you'll learn that in calculus. You will learn all of this. Everything I'm showing you tonight, you will see in AP Calculus. So, let's go ahead and do another one. Let's take the limit as x approaches 0 of the following. So I have x squared times cosine of 5 over x. So if I plug in 0 here, what do I get? I get 0 squared is 0 times cosine of 5 over 0. All of a sudden, this is automatically undefined because I'm dividing by 0. So that makes this whole thing undefined. can I do limit as x approaches pi of the square root of 3 plus arctan of 1 over x? I'm going to write that down to do later. I'm probably not going to do that one tonight, but I'm going to write that one down for a note for later. So, cosine is an interesting function because, like sine, well, first off, we know that x squared is unbounded. Is cosine bounded? And if so, what are its bounds? Always says yes, cosine is bounded between -1 and 1. Yeah, so cosine is bounded like sine. So between -1 and 1. Have a good night, Will. Thank you for joining us. So, we know from... What about tan or other trig? That's a good question. So, tan is actually doesn't play by the same rules because so tan looks like this. So I'll show you tan. So tan x. That is what tan looks like. As you can see, I have vertical asymptotes here at about, so this is what, pi, I think this is pi over 2. Yeah, this is pi over 2, this is 3 pi over 2, this is negative pi over 2, and negative 3 pi over 2. So, as you can see, unlike sine and cosine where I have a wave, here I have something that's a little more complex. Thank you, Spooky, for sharing the live. Every odd integer. Yes, that's right. That is absolutely right, Hefe. So here, what I'm going to do is I'm going to go ahead and say the following. I'm going to say that the cosine of 5 over x is between -1 and 1. Because remember, I'm not interfering with the amplitude, I'm only interfering with the period. But it's not going to affect this bound. So remember, I want to make my middle look exactly like this. So again, so what I'm going to do is I'm going to multiply x squared. So here, if I have x squared, that means that, or, yes, let's try that again. So I have x squared here, meaning that, am I going to have to flip my, my inequality signs or no? Always says no flip. Yeah, that's right. I don't have to flip. Why? Because no matter what value of x I plug in here, x squared is always going to be positive. So I don't have to worry about worried about multiplying or dividing by a negative. So here, I'm going to have negative x squared is less than or equal to cosine to x squared, cosine of 5 over x, which is less than or equal to x squared, positive x squared. There we go. So now this matches that. So now I can take my limit. So I have limit. Sorry, just joined, but why negative 1 to 1? Good job. Good question, Cyanide. It's because cosine is a bounded function, and its bounds, it can never be less than negative 1, nor can it ever be greater than 1. So if we look at the graph of cosine, so cosine of x, we can see that it stays forever between negative 1 and 1. Is it squeeze theorem? Yes, it is. That is exactly what we're working on tonight, Cyanide. Thank you, Byron, for the follow. So, now, I'm going to go ahead and take my limit. So I have limit as x approaches 0 of negative x squared is less than or equal to the limit as x approaches 0 of x squared times cosine of 5 over x, which is less than or equal to the limit. So when would the bounds flip? That's a good question. So so my inequalities flip whenever I'm multiplying or dividing by a negative number. No problem, Cyanide. No problem at all. So here, I have limit as x approaches 0 of negative x squared. Well, if I plug in 0 here, I get 0 squared is 0, and negative 0, well, that's just 0. I'm going to move that over a little bit. X squared cosine 5 over x. And then if I plug in 0 here, I get 0 squared, which is also 0. So since this has to be between 0 and 0, then by the squeeze theorem, limit as x approaches 0 of x squared times cosine of 5 over x is equal to 0. And that's it. Thank you, Owen, for sharing the live. So here's what we're going to do next. First, because I have this. Thank you, Irvin, for the follow. So I'm going to go ahead and turn the page. And actually, you know what? Let's try that problem that I got. Since we're going to need squeeze theorem for it, I think. Let's see if we can use squeeze theorem for it. Limit as x approaches pi of the square root of 3 plus arctan of 1 over x. So, here, let's see what the graph of arctan looks like. And I haven't seen it in a little bit. Where's arctan bounded? We can see that it's bounded, and it looks like there are horizontal asymptotes. But where are they? Oh, that's right. That's right. It's negative pi over 2 to pi over 2. Right. So we know that arctan it's on the open interval, so it can't equal. Here's arctan of pi over 2. Arctan of pi over 2, I believe, is undefined. No, it's not. I'm wrong. Is less than or equal to pi over 2. So my goal is to get the inside to look like this. So arctan of x, remember, if I have a trig function in parentheses, it's not going to mess, whatever's inside the parentheses isn't going to impact the bounds. So I'm going to go ahead and rewrite it as so. Arctan 1 over x less than or equal to pi over 2. So now I'm going to go ahead and add. So I'm adding 3 here. So I'm going to add 3 to both sides. So I have plus 3 plus 3. So this is going to be 3 minus pi over 2 is less than or equal to 3 plus arctan of 1 over x is greater than or equal to 3 plus pi over 2. Nope, this is an addition sign. Sorry, I should have made it a little clearer. My pen, for some reason, is choosing when it wants to work and when it's not going to work. So yeah, sorry, that should have been a plus sign. My pen just didn't write it well enough. But anyway, back to this. So here, now, I'm going to go ahead and take the square root of this. Now, because arctan is bounded between negative pi over 2 and pi over 2, if I add 3 to that, then I know that this is going to be positive. Thank you, Gen T, for the 10 more roses. So 3, no matter what arctan is, like that, because it's bounded between negative pi over 2 and pi over 2, if I add 3 to that, even if it's negative pi over 2, this is still going to be positive. So therefore, I don't have to worry about that being I. So I'm going to take the square root of everything. So I have the square root of 3 minus pi over 2 is less than or equal to Yep, this is squeeze theorem. Why am I 3 plus arctan of 1 over x is less than or equal to the square root of 3 plus pi over 2. You start Calc 2 tomorrow? Awesome. Good luck, Sonder. So now from here, I'm just going to take the limit of everything. Because now I have this. So now, I'm going to go ahead and take the limit as x approaches pi. So now, limit as x approaches pi. I feel like I'm missing something. Thank you, ISI, for the follow. What am I missing? Oh, no. These are two different numbers, and when I take the limit, I'm gonna end up with two different numbers. Right. So still, my goal is to end up with the same number here and here, but I don't. Why is that? What do you think? What am I missing here? Square root cannot be negative. Right, but it's not going to be negative. Oh, arctan. Oh. No, arctan and tan are two different. Arctan of 1 over x and tan of 1 over x are two different graphs. But it shouldn't matter. Arctan of 1 over pi, do we have to use... Oh, do we? No. It's defined at 1 over pi, isn't it? One over pi. Why isn't this work? Why isn't my calculator working all of a sudden? Second quit. Second. All right, time to go get the other calculator. And this one's dead. Time to get my phone. I will be right back in just a second. Well, I completely forgot that my phone was charging out in the living room, so let me go ahead and do that. Yeah, so square root of 3 plus arctan of 1 over pi. Yeah. So it's about, that's our answer. Why do you need these inequalities? Turns out I didn't. Thank you, Dilo, for the follow. Thank you, Takara, for the follow. Thank you, Fadumam Hamoud, for the follow. And I'm sure I pronounced that incorrectly, so I apologize for that. But yeah, so turns out we actually don't need the squeeze theorem for that. It's just direct substitution. So, yeah. Lesson learned. Stick to my own problems, or make sure that the problems I get are... Thank you always. I really appreciate that. Like that. One thing I'm not afraid to admit is when I make a mistake. And sometimes it takes me 10 minutes to figure out that I'm doing something that I don't need to. But that's the thing, right? Sometimes, like you just saw with me, sometimes all the stuff that you know ends up overcomplicating problems that really didn't need to be that complicated to start with. Is this Calc 1? This is indeed. We're human, we make mistakes, 100%. So, awesome. Cool. All right, on to the next one. So, for example, and I always tell my students, make sure you can do direct substitution. Try direct substitution first. And as you can see, I didn't. I just automatically assumed that we had to use the squeeze theorem when I could have saved us all a little bit of time if I had looked for 5 seconds. But hey, it is what it is. So, you're taking Calc 1 this semester as a PSEO class this semester. Do you have any tips or advice? I'm not sure what a PSEO class is. But I'll give you the advice I give my calculus students. Make sure that if you ever get lost, make sure you ask questions. Also, if your algebra and trig knowledge is good, you'll do well in Calc 1. All right. Let's go ahead and try another one. Let's try the limit as x approaches 0 of, we'll do one more like this, and then I'll do one where we might have to swap the inequalities. Sine of 5 over x plus 1. So here, I'm going to take my own advice and ask, can I get an answer just by plugging it? Or do I get an undefined answer? What do you think? If I plug in 0, yeah, exactly. That's right, Hefe. That's right, period. I don't. That's right, ISI. It's undefined. That's right, always. It's undefined. Why? Because I'm going to be dividing by 0. And remember that division by 0 is, we can't do that. So, let's go ahead and let's see if we can't use the squeeze theorem here. So, I'm going to have, remember that sine is a bounded function. So I'm going to have sine of 5 over x is less than, or yes, good job. Let's try that again. Is this calculus? Absolutely. This is calculus. So it's going to be between -1 and 1. Because remember, the sine is bounded between -1 and 1. So, thank you, Yippee, for the follow. Dual washer problem. So tonight I'm going to focus in on squeeze theorem, but I'll definitely add washers to the list. So where is my list? Here's my list. So washers. Washers are fun. Love this. Thank you, Vicky. I'm really happy to hear that. Is there another way to get an undefined answer besides division by 0 or square root of x? Thank you, Ian, for the follow. Infinity over infinity. Right. I was actually just about to say that, Hefe. But yeah. Infinity over infinity or any other form of indeterminate form. There are a few. Riemann sums are already on the list. Right there. Or 0 to infinity. Yep. Cool. Yeah, so here, What I'm going to do next is I'm really tempted to add 1 here, but I'm not going to. Instead, I'm going to multiply by x squared first. So if I have x squared, then on this side, negative 1 times x squared is going to be negative x squared. Thank you, Vicky Sewing Company, for the follow. Is less than or equal to x squared sine of 5 over x, which is less than or equal to x squared. So from here, now I'm going to add the 1. So I have negative x squared plus 1 is less than or equal to x squared sine of 5 over x plus 1, which is less than or equal to x squared plus 1. So now from here, does my middle match this? Does this, other than the limit, does this match that? Yeah, it does. It does match. So now that this matches this, I'm ready to take my limit. So I have limit, and this time I'm going to make sure I have enough room. I give myself enough room. So limit as x approaches 0 of negative x squared plus 1 is less than or equal to the limit as x approaches 0 of x squared times sine of 5 over x plus 1, which is less than or equal to the limit as x approaches 0 of x squared plus 1. So now from here, I am ready to plug in 0 for my leftmost limit and my rightmost limit and see what I get. So if I plug in 0 here for x, I get negative 0 squared. Well, 0 squared is 0, and negative 0, that doesn't make sense. So it's 0. 0 plus 1 gives me 1. How about here? What is the limit as x approaches 0 of x squared plus 1? Always says 1. ISI saying 1 left and right. Baby Kimchi saying bringing me back to my high school days. How are you doing, by the way? But yeah, it's going to be 1. So now this limit is between 1 and 1. Well, oh, I have to include my equal sign. I can't forget that. That's very important. So I don't know about you, but I can't think of a number that's both less than 1, and greater than 1 at the same time. I mean, maybe there is, but I can't immediately think of it. So, but I do know a number that's both equal to 1 and equal to 1, which means by the squeeze theorem, the middle would be 1 as well. That's right, ISI. Therefore, by squeeze theorem, theorem, limit as x approaches 0 of x squared times sine of 5 over x plus 1 is equal to 1. And that is it. You're such a great teacher. Thank you, Vicky. I'm really happy to hear that. I'll be honest, I try. I'm not perfect. And a while ago, I think even sometimes now this still kind of catches up to me. I used to be a really bad perfectionist. So if I made a small mistake, it would just be like, okay, it's over. And sometimes if I make a mistake, I still find myself getting into those thoughts of being a perfectionist. But then I have to remind myself, you know what? This is math. This is not the end. Making a mistake on a problem is not the end of the world. Thank you, Chris, for the follow. As an English major, you make math so understandable. I hardly remember the formulas, but you make it so easy. Thank you, Nivek. I'm really happy to hear that, and thank you for the follow. Thank you always. You have really clear explanations. Thank you. I try. I like to teach either how I was taught or how I wish I was taught. I just graduated from UC Berkeley as a math major and would have loved to have seen your channel. Thank you. Congratulations on your graduation, by the way. How would the arguments change if it was an x cubed? Do you want to see? Cool. Let's do it. So now I need to make sure I have enough room for this problem. So, limit as x approaches 0 of x cubed times, let's do sine. We'll do another one like, actually no, let's do cosine. I want to switch between sine and cosine. Thank you always for the follow. 1 over x. So, here's what I'm going to do. I still have division by 0 here. So I know that I can't just directly substitute in. So what I'm going to do is I'm going to use the squeeze theorem. So again, just like before, I'm going to start with the following. -1 is less than or equal to x cubed. No, not yet. Not yet. I'm getting a little ahead of myself. Is less than or equal to 1. Thank you, Andre, for the follow. Thank you, Jen, for another heart me. So, what I'm going to do here is now I'm going to multiply everything by x cubed. So, unlike x squared, is there a situation I thought it can't equal to 1? No, it can equal 1. Cosine fluctuates between -1 and 1, but it can equal 1. In fact, there are many places where cosine is going to equal 1. For some reason, like I said, I misplaced my unit circle and I haven't been able to find it over the last couple of days. I hope I didn't accidentally throw it away. I was cleaning the other day and I'm sad I missed when he explained what squeeze theorem is. No problem. I can explain it now. So squeeze theorem says the following. And then I'll go back to that problem. So squeeze theorem says that if I have 3 functions that have this relationship, then at some point on the function, or let me say this. F of x less than or equal to g of x, which is less than or equal to h of x. And at some point, when x equals a, if f of x equals h of x, then f of a, which equals h of a, so f of x equals h of x, but these two are equal, so therefore, because g of x is always between f of x and h of x, g of x would also equal f of x or h of x at that point. So with that, let's go back. So now, from here, now we have to consider x cubed. So x cubed can be either negative or positive, which means that, actually, I'm sure this is not the way to do it, but I'm going to do it this way. So let's consider 2 cases. So if x cubed is less than 0. So how do I define what a... So I look at the... So here, because I'm dealing with trig functions, I look for what the bounds of that function, of that trig function are, and I let that be my f of x and h of x. But sometimes, even if I don't, then sometimes we run into problems where it'll define it for us. Like if it says find the limit as x, like, let me show you the first one. Like here, when we had to evaluate the limit as x approaches 2 of f of x, it gave us f of x and h of x. And we had to find the limit of g of x as x approaches 2. So sometimes we're going to be given... Oh, I realize now that that should be equal. But yeah, so that's how we define it. Either we look at the bounds or hope it's given to us. Thank you, Nasser, for the follow, and I apologize if I butchered that pronunciation. So here, if x cubed is greater than 0, then that means that I have to flip these two signs. So that would mean that negative x cubed is greater than or equal to x cubed cosine of 1 over x, which is greater than or equal to x cubed. And here, if x cubed is negative, then negative x cubed, negative times a negative is a positive, so that would just be positive x cubed. And if this were negative, then it would be negative x, or if x cubed were negative, this would be, yeah. Did I do that right? I think I did. Wait a minute, no, this should still be negative. So anyway, I am here. Cosine of 1 over x less than or equal. Okay, so now because this matches this, I'm ready to take my limit. So I have limit as x approaches 0 of negative x cubed is less than or is greater than or equal to the limit as x approaches 0 of x cubed times the cosine of 1 over x, which is greater than or equal to the limit as x approaches 0 of x cubed. So from here, I need to find the limits of these numbers. So when I plug in 0 into my leftmost limit, what do I get? What would my answer be to this left-sided limit? I have to be careful not to say left-sided because that's a different thing. Thank you for the fingers, Gen T. Dad says 0. Yeah. So this is going to be 0. 0 is less than or equal, or greater than or equal to, rather, the limit as x approaches 0 of x cubed times cosine of 1 over x, which is less than, what is the limit here? Thank you, Dylan, for the follow. It is again 0, right? So 0, I don't know about you, but I can't think of a positive or negative number that satisfies this equation. So if x cubed is less than 0, the limit as x approaches 0 of x cubed times cosine of 1 over x. 10K, yay, let's go. Is equal to 0. Bro, I'm struggling with polynomials. What is this? Any tips? Thank you, Garnett, for the follow. Thank you, Joel, for sharing the live. Any tips on struggling with polynomials? So, That is a really good question. One that I wasn't honestly prepared for tonight. So if you're struggling with polynomials, have you tried asking? I would first try asking your teacher. They're trained to help with that. But as far as any tips with solving them, find the method that works best for the individual problem. So sometimes factoring works. Sometimes completing the square works. Sometimes the quadratic formula works. If it's not obvious that you can factor it, then I would try the quadratic formula. That'll pretty much always give you your solutions. Anyway, we've tested one case. Now we need to check if what happens if x cubed is positive. So, no problem. I'm happy to help. I am always happy to help. If x cubed is greater than 0, then I don't have to flip these signs. So therefore, I have negative x cubed is less than or equal to x cubed times cosine of 1 over x, which is less than or equal to x cubed. And just like before, because this matches this, then I can find the limits of the inequality. So I have a limit as x approaches 0 of negative x cubed is less than or equal to the limit, and I need to make sure I gave myself enough room. I should have given myself enough room. As x approaches 0 of x cubed times the cosine of 1 over x is less than or equal to the limit as x approaches 0 of x cubed. Do I end up with the same situation? Do I end up with this? Or do I end up with something else? Dad says, yeah, awesome. Yeah. So, when I plug in 0 for x's, ideally, I get 0. That's going to be 0, and that's going to be 0. So I get 0 is less than or equal to the limit as x approaches 0 of x cubed times the cosine of 1 over x. Oh, I have to move my mouse, otherwise TikTok's going to think I'm inactive and make me do the puzzle piece. So I'm going to go ahead and move the mouse so that way it doesn't deem that I'm inactive even though I'm talking to you all. So I get 0 is less than or equal to this, which is less than or equal to 0. Well, the only thing that's actually there is no number that I can think of that's both greater than and less than 0. So I have to go with this equal. So therefore, if x cubed is greater than 0, then the limit as x approaches 0 of this is equal to 0. Now, final question for this problem. Do I get the same answer here and here? This is giving you PTSD. I'm sorry, Goku. What questions do you have about this? Thank you, Cyber, for the follow. You can't quite see the emoji that you have, abracadabra. Strangely, I'm finding this very entertaining. Maybe it's because I don't major in math, but I do understand it. Awesome. What math is this? This is calculus. So I've shown whether x cubed is negative or positive, I still end up with the same answer. So therefore, by the power of the squeeze theorem, the limit as x approaches 0 of x cubed times cosine of 1 over x is equal to 0. So I forget who it was that asked me what happens when the argument's execute, but this is what happens. It was... I have to search. Zaki, does that answer your question? Thank you, GT, for the follow. I'm not sure what WLLG means. I'm sorry. I'm a millennial. I'm not. Fair enough. I just looked it up. Excellent, Dad. Thank you for that. So now, with that, I think that it's time for the final problem. So I will need to turn the page for this one. And on to the final problem. Let's see if we can't get to 20k likes before the final problem. I haven't seen 20k in a little while. So let's see if we can't get to 20k. And while you do that, I'm going to go ahead and check and see if I've missed any comments. Because I have a feeling that I missed one. So, let us see. If I went all the way from the beginning. Alright, so those are all the people that joined. Alright. Alright. Do we have any missed I remember those comments. I remember those. Let's see. I remember all of these, so I think the ones I would not remember are the ones that just came up recently, theoretically. So, there is a new message. That reminds me when I was tutoring in college. Awesome! What were you tutoring? And also, is there a particular story that you that makes you remind you of tutoring? Because here's the thing, I like to I like to hear from you as well. Calculus 1, 2, and 3, awesome. Calculus is one of the I don't know about you, but I have a ton of fun tutoring calculus. It's my favorite thing. Oh, I do remember someone asked me what I tutor, and so I have an entire list. Here it is. Actually, I'll need these in a few minutes anyway, so it's good that I have it. So, so I don't remember who it was that was asking me about what I tutor, but here is the list. Now, like I say all the time, just because a subject isn't on here, it doesn't mean that I don't tutor it. It just means that I'm not as comfortable tutoring it, or I'm not as familiar with the concepts. Like, I've tutored physics before, but I've forgotten a lot about physics, so I would have to go back and teach myself before I could teach. Before I felt comfortable adding it to my list. Where is organic chemistry? I'm lucky I barely remember any chemistry. I haven't taken chemistry since I was a junior in high school. And that was back in 2009. Have I done any theory classes? I can't say that I have. Or if I have, it's been a long time. But I am always interested to learn about theory. Solid channel, I think. Thank you, G-Man. I'm really happy to hear it. I definitely try. Like that, I'm not perfect. I'm still learning a lot. I'll be honest, I have to post more shorts more often. And yeah, so I always forget. I always say I'm going to post, but I never find the time to do so. So I have to find time to do that. Euclidean geometry, JK, I don't even know what that is. Okay, so Euclidean geometry is the geometry that you learn in high school. I love differential equations. Differential equations humbled me a lot when I was in college. Thank you, Venom, for the follow. So differential equation. So, all right. Keep my. Like I said, let's get to 20K problem. Let's get to 20K likes before the final problem. But while you're liking, I'll tell you a story. So I was in college and I had just taken AP Calculus the year before. So I took Calculus 1, almost slept right through the entire class and got an A. Calculus 2, same situation. It was to the point where I was tutoring kids in Calculus when they were literally lining up asking me for help with Calculus. So I thought to myself, if calculus is this easy, then college math is going to be wicked easy. Yeah. And then came differential equations my first semester sophomore year. That threw me for a loop because it took me like 2 weeks to figure out that I was struggling. And I still have a theory that my teacher curved the grades, but I can't prove it. But yeah, so I remember differential equations. Like I said, I haven't taken differential equations since, but I taught myself the stuff that I didn't remember. And sometimes I'll even still go over it just to make sure that I got it down. I have Introduction to Data Science. Awesome! I don't know what that class entails, unfortunately. Did I ever take a topology course? If so, how was it? I did not, but I wish I did. So here is how so I went to a small college, a small Catholic school where there were only like 2 or 3 math professors. So when you take math there, everyone takes Calculus 1. Actually, let me show you. So everyone takes Calc 1 and Calc 2 their freshman year. Unless you pass your AP exam. And then, once you are done Calculus 1 or 2, you go into a 3-year cycle. I'm going to call it A, B, and C. And I'm going to call it A, B, and C because this is the order in which I took it. I'm not sure which one is A, which one is B, and which one is C. So, in my year A, it was differential equations. And it was this class called Abstract Algebra. Although when I took it, it was called Modern Algebra, but that's exactly what that is. I probably should have spaced these out a little bit more, so let me do that. So this will be B, and this will be C. So in year B, we took Calculus 3, and we took what was called college geometry, which, if you ask me what it is, I'm not necessarily sure, but it was like it had non-Euclidean geometry in it. And then in year C, we took linear algebra, and I took intro to real analysis. Thank you, user, for the follow. No electives. Oh, I took electives. This was just the math cycle. And then on top of this, we took what was called a math seminar class, where every math major came in, and we would just talk about math for an hour, or whatever topic we wanted to talk about that week. So so also with the math, is this like a college math roadmap? Nope. This was just the cycle that I took when I was in college. Yet again, we had a smaller math department, so we only had so many options. I didn't go to like a big university where there are like 20 math professors all teaching different things. I feel like I'm missing something here. So, the higher you go up in math, things can get very complicated. Yeah, so I've heard rumors, and I know there was someone in here that said that it was you. So the thing about math is that I've heard stories that once you get past a certain point, you stop seeing numbers altogether. Or the highest number you see is like 10. Topology is the worst. I've never taken topology. I've wanted to take it, but I've never have. Is this the path I should take? I recently got my GED at 21 and want to go for computer engineering. It's really up to you. I would definitely recommend that you at least take calculus 1 and 2. Now, engineering will probably require you take differential equations as well, or maybe calculus 3. But I'm not sure because I didn't take engineering. I wasn't in engineering. I was in teaching. So what happened was, because I was teaching, I could skip one of these math classes, and I ended up skipping linear algebra, so I had to teach it to myself. My friend is getting her PhD at Georgia Tech in math. Her thesis is on, I imagine it is, but congratulations. I hope she gets it. Donut equals mug poo. Yep, that's right. Should I take AP Pre-Calc over the summer and then take AP Calc senior year? AP Pre-Calc, is that even offered during the summer? I don't think it is. I think since you have to take the AP exam, I've never heard of an AP exam being offered in the summer. If you're still here, Hefe, what say you? I've never heard of it, but what about you? Have you heard of that? Donut indeed. So yeah, let's go ahead and do the final problem, and then we'll call it a night. So, let us find the following. Let's find, where did my list go? Oh, there it is. Let's take the limit as x approaches 0 of there's a fun one I saw. I think it was like, let me see. I need to check something quickly before we continue, because I found a fun one that I really liked, but I forgot to write down. Oh, there it is. There it is. That's a fun one. Let's do it. So I have limit as x approaches 0 of x squared times e to the sine of 1 over x. A little bit of a different one, but nothing I don't think we can't handle. So, what I'm going to do, if I plug in 0 here, is this going to be, do I get anything, or is this undefined? What do you think? Period says undefined. Yeah, it is undefined. Why? Because if I'm going to have division by 0, even in the exponent, I can't have division by 0. So, what I'm going to do is I'm going to go ahead and try the squeeze theorem and see if it's going to work. So, x squared is unbounded. E to the x, is that bounded or is that unbounded? Or, yeah, e to the x. Bounded or unbounded? What do I mean by bounded? That's a good question. What I mean by bounded is there a maximum value that this can have and a minimum value that this can have? For instance, sine is bounded. Sine is bounded by -1 and 1. Right, Robert. Awesome name, by the way. E to the x is unbounded. Because its maximum can be as high as infinity. What if it was 0 over 1? 0 over 1 is going to give me 0, so it would be defined. So if this were x over 1, then yes, this would be what? This would be sine of 0. Sine of 0 is 0. And e to the 0 is 1. 1 times x squared is x squared. 0 squared is 0. Yep. Yes. So we know that sine is bounded. So it's bounded by -1 to 1. I'm going to go ahead and write that down. And then from here, what should I do next? Should I involve e, or should I multiply by x squared? What do you think? Raise e to this or multiply x squared? You can work in data science analyst or be a quantitative. Good to know. The limit would be 0 since there are no constraints. Doesn't e of x have a horizontal asymptote? It does. It does indeed. It's going to be 0. Or the asymptote is 0. So, here, what I'm going to do is I'm not going to multiply, because what am I multiplying x squared by? I'm multiplying x squared by e to the sine of 1 over x. So, in order to be able to multiply x squared, I need to first have e. Doesn't that mean it's bounded? No. If it had horizontal asymptotes on both sides, then yes. But e to the x can go to positive infinity. Yeah, no problem. So, here, what I'm going to do is I'm going to raise everything. I'm going to raise e to everything in my inequality. So I have e here, and e here. Excuse me. So, here, e to the negative first. I'm just going to leave that as e to the negative 1. And that's going to be less than or equal to e to sine of 1 over x. And then it's going to be less than or equal to e. Now, let me ask you a question. and I think you already know the answer because I saw that you answered it already. Do I have to flip the signs? Do I have to flip these inequality signs when I raise it? When I raise e to it, e to that power. Right, AAC, and I guess I'm kind of technically being loose with my definition of unbounded, but exactly. So actually, let me ask you the same thing a different way. Can e to any power ever be negative? Right, Sammy, it can't. So I don't. Do I have to flip these signs? No, I do not. Oh, by the way, are you okay if I don't write e to the first here? Because e to the first is the same as e. We're in agreement? Awesome. So, what I'm going to do now is I'm going to multiply by x squared. So again, x squared is always positive, so I don't have to worry about flipping the sign. So I have x squared times e to the negative first is less than or equal to e to the sine, or I need to include it. So x squared e to the sine, e to the sine of 1 over x. This is not on the SAT. Nope, it is not. If this were on the SAT, then it won't. It's not on the SAT. Nope. You might find I'm not even sure you'll find e on. If we multiplied only by x, which can be negative, yep. So if we were multiplying by x, then we would have to consider both if x were negative and x is positive. That is a good question, kitten lover. That is a really good question. Right, we would have two cases. But either way, they would show the same answer. Or maybe not. That would be up to the problem. You're most certainly welcome. So now, let me ask you a question. Does my middle expression match what I'm taking the limit of? Yeah, it does. So now that it matches, even though I don't seem to be able to know what I'm writing, I can now take the limit of everything. So I have limit as x approaches 0 of x squared times e to the negative 1 is less than or equal to the limit as x approaches 0 of x squared times e to the sine of 1 over x, which is less than or equal to the limit as x approaches 0. I almost forgot to write the limit there, of x squared times e. Now, I'm going to go ahead and plug in 0 for x here, and 0 into here. Can you show proof e is irrational by Taylor expansion? I'm actually I could do that. I'm just sticking with squeeze theorem tonight, though. What class is this for? This is calculus. This is calculus. Yeah, no problem. I'll add it to the list, though. So, Taylor expansion. I wanted to... Oh, no, wrong list. Wrong list. This is the list. Taylor expansion. Proof. So, yeah. Now I may have to rewrite that list. That would be bad. Anyway, so if I plug in 0 for x to this left side, what would I end up getting as an answer to this limit problem? Sammy says 0. Dad says 0. You just blew my mind, dude. I finally understand applying. You're most certainly welcome, Matthew. I'm really happy to hear that. So yeah, so this limit is 0, which is less than or equal to the limit as x approaches 0 of x squared times e to the sine of 1 over x. And now, what about this side? Zero as well. That's right. That is absolutely right. So now, I don't know about you, but I can't think of any numbers that are both less than and greater than 0. That actually sounds kind of strange if you think about it. But I do know a number that's equal to 0. So therefore, by the power of the squeeze theorem, the limit as x approaches 0 of x squared times e to the sine of 1 over x is equal to, so the answer is 0. Yes. And that is it. That is the squeeze theorem. So squeeze theorem is just a proofy thing. It seems like the answer is always equal to the number x approaches. Not always. That is not always the case, but most of the time it is. Like here, when I did this problem, the answer ended up being 1. So if this number and this number are the same, then that is my answer. Is the 1 in the middle also 0 for the last problem? Yes. Is squeeze theorem usually done on trig functions only? I haven't seen it. I haven't seen it done with any other problems. That doesn't mean that it's not. I just haven't seen it. Not really. Consider cosine x as x approaches 0. For which one? For this one? Oh, or are you not? I don't know if you're talking to me or I'm not sure what problem you're talking about. Oh, no problem. No problem at all. Cool. Awesome. So with that, I will go ahead and do my little ending spiel, and then I will go ahead and call it a night. Or should I say morning, because it is almost 2 a.m. where I am. Right. And I have to say before I do this, before I do my little ending thing, you may also hear this called the sandwich theorem. Just know that the sandwich theorem and the squeeze theorem are two different things. Though, I wonder if the person who called it the sandwich theorem called it that because he was hungry for a sandwich. I don't know. That was my bad attempt at a math joke. What about Simpson's rule? What about it? I'm about to take Calc 2 again, but it's been 2 years and I've forgotten everything about it. That's okay. How do I remember? So so it's been 2 years since you took Calc 2. I for some reason I almost I almost read that wrong. I'm like, no, I read it as Calc 2 again, but I'm like, are you taking? When was the last? Have you taken Calc 2 before? I almost asked you that. So, yeah. How do you remember? So I find that looking at problems, watching videos, stuff like that tends to help me remember topics that I haven't done in a long time. Um, I know YouTube's a great pro. Oops, I said it. So now I'm going to be dinged. Great. Um, but yeah. What about Simpson's rule? Does Simpson's rule matter for anything? So Simpson's rule has to do with integration. Right now we're just focusing on limits. So Simpson's rule talks about approximating under area under the curve by using parabolas. You must be good at physics. It has been a long time since I've done physics. I can get away with some physics problems, but when will you do Calc 3? Right now I'm doing vectors. I may or may not have a couple Calc 3 lives planned within the next couple weeks. I want to finish up stuff on derivatives first. Nope. Physics isn't just trigonometry. Physics is a lot more than just trig. Physics involves trig, but okay, do you have Calc 3? Not yet, but I'm gonna be making some videos this week. I want to try and start a Calc 1, a Calc 2, and Calc 3 series over there. So I'm gonna start working. I've already started to work on those videos. They should be out soon, or at least the first couple episodes. Calc 3 isn't required for a biology major over only Calc 2. Okay. Yeah, I don't like. I didn't. I majored in math. I didn't major in biology, so I'm not sure what's necessary for um biology. I missed a comment. Awesome. Thank you, Dad. I'm really happy to hear that. I am really happy to hear that you enjoyed it, and I hope everyone enjoyed the live tonight. So, with that said, let me go ahead and any tips for differential equations? I just started the class last week. Differential equations gets really involved really quickly. So, how well do you do taking integrals, Neil? Real analysis haunts me in my dreams. I actually enjoyed when I took intro to real analysis. I never took real analysis. Do I know people who teach thermodynamics? I can't think of anyone immediately off the top of my head, but if I find someone CRZ, I'll let you know. Yeah, like I said, I hope you did pretty good. Okay. Yeah, so differential equations is gonna be integration heavy, or at least I found it to be. So make sure that what was it? It's gonna be knowing your integration is going to definitely help. But I think that when it comes to differential equations, you'll want to make sure that you don't fall too far behind like I did. Because like I said, differential equations gets really complicated really fast. So if you get lost and you're like 2 weeks behind, you're gonna get even further behind. What about linear algebra? Linear algebra, I like that. I didn't take linear algebra when I was in college because I was student teaching, so I had to teach myself linear algebra. Linear algebra, if you if you're yeah, if you understand matrices well, you'll do fine. Because linear algebra is a class to teach you how to do more complicated systems of equations. But yeah, so anyway, I'll go ahead and do my little thing right now, and then we will call it a morning, for me at least. I don't know what time it is where you are, but for me it is in the morning, is Monday morning. So, if you want to find me here, this is my channel over there. So if you do these 5 things, that would be great. And like I said, I'm working on a Calc 1, a Calc 2, and a Calc 3 series right now on here. So go ahead and follow me there. So I have one here, and I have one on TikTok, which is what you're currently watching. But this is my channel on this app. And then there are a couple other TikTok channels that I highly recommend. The first one is ACG Math Tutoring. So if you're looking for help with your your ASVAB, your Accuplacer, your GED, or the TEAS test, you should follow ACG Math Tutoring. Audrey was the one who convinced me to join TikTok, and so I like that. I've known her for 6 years, so I highly recommend you follow her. Also, if you're interested in learning about the abacus, or if you want to follow me into that live, I recommend following Learning with Lynette. She's actually live right now, and that's actually where I'm going to be as soon as I end this live. So, I highly recommend following those two, and I'm always looking for more people to recommend. So, I'm definitely so yeah. Also, as I said before, or I don't remember if I said it or not, but if I haven't, I'll say it now. I offer online math tutoring. I offer it as groups, and I offer it one-on-one. So I'll start with the groups. So I offer group tutoring to groups of 3 to 10 students who are all taking the same course at the same time. Now, that doesn't mean that you have to be taking it with the same exact teacher or even at the same exact school. As long as you're taking the same class, it doesn't matter where you and your friends are. So if 3 of you are taking geometry with 3 different teachers at 3 different schools, you can still sign up for group tutoring, and it would cost you $35 per hour per person. And if you are interested in one-on-one tutoring, I'm running a special right now. So normally, I charge $100 an hour for tutoring. But if you sign up for weekly tutoring from now until August 31st, I'm going to lock you in at $60 an hour. So even after August 31st, if you sign up before then, you'll pay that rate even if you go past this date. But if you wait until after August 31st, if you wait until 12:01 a.m. on September 1st, my rate goes back up here. So with that, I think that is all I have for this evening tomorrow we're going to be talking about something that I think I should have talked about a while ago, but I forgot, and that is going to be continuity. So we're going to be focusing on continuity tomorrow. So with that, I hope you actually, I wonder. All right. So anyway, I hope you all had fun. I know I had fun. And I will see you all again. So, I go live every day at 11 p.m. Eastern Time. And it's Eastern Time because I live in the eastern part of the U.S. So, that's why that time. Anyway, I will see you all tomorrow at 11:30 p.m. Eastern. Have a great rest of your day, everyone. Bye now.